Hey everyone, today we're going to talk about the Hagen-Poiseuille equation. So this equation helps us understand the flow of blood around the body, and we can apply it to nearly all blood vessel or capillary networks. So the flow of blood is determined by the pressure gradient applied, the vessel length, and the diameter and viscosity of blood. So it was essentially discovered by Poiseuille, who studied using rigid, uniform, unbranching glass capillary tubes, the steady laminar flow of Newtonian or homogeneous fluids, and described their mathematical relationship. So the equation that was developed is flow equals pi times the pressure difference between the start of the tube and the end, times the radius to the power of 4, over 8 times viscosity times length. And viscosity is represented by the little n symbol here, and length by L. So let's just draw this for a vessel. Now we have our vessel here. You have a pressure at the start and a pressure at the end, and this is the pressure difference. And you always go from high pressure to low pressure. Then in green, we have the radius of the vessel. So you want to figure out the area, but it's to the power of 4. Not squared, so it's pi r to the power of 4. And this is important when we talk about resistance, which I'll talk about in another video, as our radius is incredibly important, or the most important factor when it comes to resistance. And it also is important in flow as well, as an increased radius exponentially increases flow compared to a decreased radius, as it's to the power of 4. And then at the bottom of our equation is 8 times viscosity, represented in orange here. So this is the density or the viscosity of the blood. And then the length of our tube. And this will determine our flow. But it's important to mention here, this is only for laminar flow in a tube. And laminar flow consists of concentric fluid cylinders sliding over each other. And the central cylinder has the highest velocity, whereas the outermost cylinders adjacent to the vessel wall are largely stationary or very slow. And the profile of the flow velocity across the tube is parabolic, which is represented here by the middle flow lane being further and at a higher velocity than the outer flow lanes. It's also important to mention here the term pi over 8 is determined or obtained by a constant from the mathematical relationship of volume passing per unit time, and that's why it's pi over 8. In my next video, we'll talk about resistance and hydraulic resistance to blood flow, which is another variable that we need to take into account when we talk about organ-specific blood flow and determinants of blood flow.